Okay, so welcome back and good afternoon. We want to look at Huawei firewall technology basis. Now, the term firewall, the word firewall was first used in the construction field. Function of a firewall is to isolate fire, preventing it from spreading from one area to another. And so that's the purpose of a firewall in the construction industry. Now in the communications field, a firewall is a device usually deployed to logically isolate networks for some purposes. Of course, this isolation is intelligent, as we are going to see. So it blocks attacks on the network while allowing communication to pass through. Now, how to use firewalls to protect networks against attacks and intrusion, how to hide enterprise internal networks. So this course will answer these questions. So by the end of this chapter, you should be able to, Marvin.
You should be able to master firewall basic knowledge and security policy configuration, master NAT principle and configuration, understand attack defense principle and configuration.
Exactly. Good. So let's begin with firewall basic knowledge. So why do we need firewalls? Now, generally, enterprises need firewalls to isolate their intranet from the extranet, the internal network from the public network. So most of the time, actually, firewalls are deployed at the border of your internal network. Most of the time, it is put immediately after the router that connects you to your internet service provider. Now, a firewall is mainly used to protect one network area against network attacks and intrusions from another network area. So, for example, in this particular enterprise, we are simply protecting our intranet from the internet. But even within our internet, we can still deploy a firewall to isolate two different LAN segments, for example. So that is how the firewall is used. So it's used to logically isolate networks, especially for security purposes. So as you're going to see, it will help us to prevent intrusion and also network attacks from one area to another area. Now, how can the switches and the routers compare to firewalls? Now, while the essence of routers and switches is forwarding data, the main purpose for firewalls is to control data, to filter data, depending on some policies. So really, firewalls, unlike switches and routers, are used to defend against attacks, viruses, Trojan horses, and so on and so forth. So some traffic, when they come in, some are blocked, some are allowed to move on. On the other hand, routers and switches, their main purpose is forwarding of data. Now, the reason as to why we are doing this comparison is because we have some of the security features like packet filtering that actually can be configured on routers. So you can do that, but again, when you do that, there are many other things that the firewall can do that the routers cannot do. The other consideration you're supposed to take is data forwarding also takes quite some processing power in the router. And therefore, when you deploy a lot of security configurations, for example, in your router, then you're going to overburden it, and processing is going to be slower because they're going to share the memory and the CPU power with the forwarding. So routers, switches are supposed to forward. So for that purpose, we have firewalls which are actually dedicated specifically for control, what comes in, what goes out, and to also defend against attacks such as viruses and Trojan horses. So that's the essence of firewalls. So if we can just look at the difference here between firewalls and routers. So just in terms of background, this one was created to cater for security needs. This one was created to cater for packet forwarding. So the purpose for this is to block any non-permitted data packets. The purpose for a router is to ensure network and data communication. The core technology that is used for firewalls is information flow filtering based on stateful packet filtering. When it comes to filtering, this one can only perform simple packet filtering using SELs. So simple packet filtering uses things like source and destination addresses and so on and so forth. But firewalls can do stateful packet filtering. So I'm going to explain to you later what stateful packet filtering is. In terms of security policies, we have some default configuration that can defend against the basic attacks in firewalls. So even without configuring it, when you just deploy it, then it can be able to attack against the common attacks, to defend against the common attacks. For this one, the default configuration does not fully take security into consideration. So you have to configure in your router clear security policies if you want it to defend against certain attacks. Impact on performance, of course, the number of rules and network address translation rules used by stateful packet filtering has a little impact on performance because a firewall is a dedicated device. It has its own CPU and memory. Here, when you do packet filtering, it has a great impact on the router's CPU and memory resources, and it may actually cause forwarding delays due to processing delays. So it is important that you don't configure a lot of security policies on your router. Attack defense capability. So firewalls provide application layer attack defense, while routers can only take care of layer 3 and layer 4. So based on IP address headers and also TCP UDP headers. But this one can provide attack defense up to the application layer. So that is the comparison between firewalls and routers. So firewall development history. The very first firewall was created in around 1989. The main purpose was packet filtering, and most of the time it was using SELs to provide access control. At around 1994, another version that could achieve stateful inspection was also developed. Then in 2004, 10 years after that, they came up with a more unified security solution called UTM, or United Threat Management. So this one, it integrated the conventional firewall functionalities. So that's why you can see Here it is multifunction. It is multifunction. So it can be able to do intrusion detection, antivirus, URL filtering, application control, mail control, and so on and so forth. So that's why it's called United Threat Management. So it can do a number of stuff together. Then in 2009, a new version of firewalls came into place. This particular version is called the Next Generation Firewalls, NGFW, Next Generation Firewalls. The main advantage over this, over UTM, is the processing speeds of this one, and it also uses deep packet inspections technology, DPI. So this one is controlled based on users' applications and contents. That means that the other advantage of next generation firewalls is that you can be able to do a lot of configuration. You can be able to do a lot of configuration and specifications. So that is how the firewalls have evolved over the past like 30 years. So Huawei firewall products, now, as you can see actually from these pictures, firewalls actually look like switches. So they come with several interfaces, what we also call ports. So they come with several interfaces in order to isolate the different parts of your network. So we are going to look into that further, but just know that this is how the back of a firewall actually looks like. So it almost looks like a switch, by the way. So Huawei provides a number of firewalls depending on the number of features they support. So they have low-end firewalls such as USG 2100 and 2200. They also have mid-range such as USG 6300, and they also have high-end firewalls. So for high-end firewalls, they require super high processing power, and most of the time are deployed at data centers. This one for enterprises, medium-sized to large enterprises. This one for small. The low end for small campus networks, for example. So those are some of the firewalls that Huawei provide, and some of the features that these firewalls provide. Other than firewall, they can also provide routing. They can also provide VPN creation and also Wi-Fi functions. Most of them are plug and play, and they're very easy to configure, especially the low end firewalls. So now let's look at what we call security zones. Security zones. So as we've said, a firewall will have many interfaces. Now these interfaces, each of the interface will actually create a different security zone. Each interface will create a different security zone. So you can have the manufacturing department there, research department, marketing manager, the DMZ, demilitarized zone for the servers, and also a connection to the internet. So that is how the firewall actually divides the security zones. So the question we're asking here is, how does a firewall distinguish now these different networks? How does it do that? Let's look into that. So it does so by adding them into what we call security zones. security zones. So a firewall uses security zones to divide networks and mark the paths of packets. So you have the firewall here. The firewall has an interface. Now, that interface actually connects to a network. That interface connects to a network, like that one, a LAN. And now, that is what now we refer to as a security zone. A security zone. Now, it is important to mention that a security zone can contain one or multiple interfaces. One security zone can contain one or more interfaces. So for example, we can have another interface here which also belongs to this security zone and connects maybe to a different network. So firewalls actually use these security zones to divide networks and to mark the packets, the paths through which the packets are going to be passing. So packets are actually controlled when traveling between security zones, as we're going to see in the next slides. Okay. So this is what I was saying. So assigning to security zones. Assigning to security zones. So we have security zone A here, we have zone B, we have zone C. Now, as you can see, these zones are actually attached to a particular interface on the firewall. So for example, this is attached to interface 4, this one to interface 3. And as we said, a security zone can actually have one or more interfaces. But it is important to mention that one interface can only be assigned to one security zone. So you can't have interface 1 here, you can't have interface 1 here being in security zone A and B. So that is not possible. That cannot happen. This is not allowed. Okay. So we're saying here you can assign interfaces to security zones in order to divide networks on a firewall. In order to divide networks on a firewall. So let's move on and look at the default security zones. Now, generally, the firewall provides several security zones. Huawei firewalls have 3 default security zones. So one is called the trust zone, the other one is called the untrust zone, and we have the demilitarized zone, DMZ. Now the trust zone usually refers to the network of internal users. So in this zone, this is where you have your internal network. So your internal network connects to interfaces that have been added to the trust zone. DMZ, of course, this is where you put your servers that you want to be accessed from within your network and from the internet too. You put them in the demilitarized zone. Then we also have the untrust zone. Most of the time, the connection to the internet, that link that is linking you to the internet is configured as the untrust zone. So because it's insecure, it is not trusted. So it's an untrusted zone. So you can see, for example, it is important to understand that when someone from your network wants to access the internet, for example, they'll have to move from the trust zone to the untrust zone. So we are going to see the implication of this. When someone from the internet wants to access your web server in the DMZ, for example, they have to move from the untrust zone to the DMZ. Now, I'm sure it's not the first time you're seeing this term, demilitarized zone. So this term actually originated from the military. So in the military, it refers to an area which is partially controlled by the military, but is also left out for the public. So it's like an area where public are allowed. So we don't have very strict military control, but also the military are also doing some operations there. So that's what we call the demilitarized zone in the military. But when it comes to communication, at the demilitarized zone, this is where we put servers, which we want to be accessed from our internal network and also from the external network, that is the internet. So let's look more into this. So the question here is how do you indicate the firewall itself? So in which zone is the firewall? To answer that question, the firewall is in a zone called the local zone. So the local zone actually indicates the firewall itself. So all packets that originate from the firewall itself are actually originating from the local zone. So that is what this means. Any packets that are being created from the firewall itself, maybe it's going to your internal network. So it's actually moving from the local zone to the trust zone. So any packets that originate from the firewall itself originate from the local zone. So a firewall provides a local zone indicating the firewall itself. Now, it is important to note that no interfaces can be added or assigned to the local zone. Reason being, actually, all the interfaces by default are already in the local zone. So you can actually see that interface 1, 2, 3, and 4 are attached to the local zone. So remember that. Okay, now local zones have different trust degrees. They have different trust degrees, which are actually quantified through what we call a security level. So for example, the local zone, which is the firewall itself, has a security level of 100, trust zone 85. So generally, trust zone refers to the area where intranet terminal users reside. For the DMZ, the trust zone, the security level is 50. Then for the untrust zone, we have a trust degree of 5 or a security level of 5. So the trust degree, as you can see from there, the one that has the highest trust is local, then trust, then DMZ, then this one is the most untrusted with a security level value of 5. So how are these values used? Let's see that here now. Now we have the concept of what we call an interzone, security interzone. Now the interzone is actually the path between security zones. The path between security zones is what we call an interzone. the path between each security zone. Now, each interzone has its own view, where most firewall configurations are actually performed, as you're going to see. What we're saying here is that this path, for example, from the trust zone to the DMZ is an interzone between the trust and the DMZ. We also can have another one in that direction when we are coming from the DMZ to the trust zone. Now, the most important concept to understand here is the concept of outbound and inbound. Outbound and inbound. So what do they mean? Now, when packets travel from a zone, with a higher, when packets travel from a zone with a higher trust value to a zone with a lower trust value, then we call that traffic flow outbound. We actually configure that traffic flow in the outbound direction. As you can see here, we are moving from the trust zone, as shown by this arrow, to the DMZ. On the other hand, when we move from a lower trust level to a higher trust level, then that traffic is in the inbound direction. So all these arrows are simply showing all the possible cases of inbound and outbound. So of course, also inside the firewall, we have the local zone, and we know the local zone has a security level value of 100. So that's why we're saying when we move from 85 to 100, that is called inbound, from low to high. When we move from high to low, that is outbound. Now, it is important to know this because now packet flow is restricted using security policies. In either the inbound or outbound direction. So security policies simply offer security checkpoints on the path. So what that means is this: you want to move from the trust zone to the local zone. So we have to check on this particular interface. We have to check the policy. Have you been allowed? Are you allowed to move from a lower security value to a larger security level? Something like that. So we're going to do that in a short while. Okay. Oh, so we have the local there. I hope you've seen it. So security zone configuration example. So we want to do this example here. Now, on a testing network shown in the figure, we have a next generation firewall which serves as a security gateway to allow users in this network 10.1.1.0, this guy. So we want guys from this network to be able to access the server on the internet 1.1.1.10. So we must configure security zones on the firewall, on the next generation firewall. So we need to configure here security zones. Now, as you can see from this figure, we are going to configure our internal network as a trust zone and the internet, where the server resides, as the untrust zone. By doing that, we are simply configuring this interface as a trust zone and this interface as untrust zone. Then we can come up with a policy to filter packets there. So how that is done, we simply come into our firewall. Then what we're doing here is simply configuring an IP address for this interface G001. We're doing the same here for this interface that is connecting us to the internet. Then after that, now this is how we add interfaces to specific zones. So here we are creating a zone called trust. So firewall zone, then we are giving it the name trust. Then we are setting the security level. To set the security level, you use the command set priority. Then we are using the value 85. Then you add an interface into that zone by using the command add. Then the type of interface, the name of the interface, then the name of the interface there. So we are adding this one to the trust zone. So anything that is connected, any network that is connected via that interface is actually in the trust zone. So after doing that, we also configure this as untrust zone. So again, the command is firewall zone, then the name of the zone. Then we set the security level using the command set priority. Then we give it a low priority value of 5. Then we do add interface G1 stroke 0 stroke 2. So once we've done that, then this will be on the untrust zone. Now, from our PC here, if we do a ping to the server at this particular point, after configuring the security zones, it's going to time out. It's going to time out. So why? Why can why users from this network cannot be able to ping the server yet? Why? The reason is because, yes, we've created the security zones, but we've not created a policy. So we need to create a policy to allow these particular packets to flow from the trust to untrust zone. We need to create that policy. Otherwise, by default, if we have not allowed it, the packets are simply going to be dropped. And that's why that ping is not working. So let's look at security policy. So the security policy, so generally, if no security policy is configured in an interzone or no security policy is matched, then the default packet filtering action is deny. So default filtering action is deny. So if we've not configured any policy or you do not match any policy, we simply deny. Of course, most of the time we use the 5-tuple information to identify different traffic, like the source address or source port number, or destination IP address or destination port number. Then the action can either be permit or deny. So in this particular example, they're just showing you that the default packet filtering for any packet is deny. So please remember that by default, firewalls will deny any packet that does not match any policy. Now, how then do we configure a security policy in the firewall? How do we configure a security policy in the firewall? So the first step is what we did here. We configured the addresses for the interface. Then we created the trust and untrust zone and added the respective interfaces. Now, after doing that, the second step should be now configuring the security policy. The commands to do that, so you do security policy, then you use the command role name, Then you give that policy a name. So we are calling this policy underscore sec underscore 1. Then we are saying the source zone. The source zone is trust. The destination zone is untrust. So we are allowing to move from trust to untrust. And for which packets? For packets that have the source address from that network. So that is how we configure the policy. And now, oh, sorry, other than the network address there, we also have the mask. So you also have to specify the mask there, as you're going to see in the lab. Then the last command is you permit. So action permit, action permit. So here we are simply saying source zone, trust, destination zone, and trust. So we are allowing moving from the trust zone, moving from the trust as the source to, to the untrust zone. So now, if we do the ping after configuring the policy, it should be successful. So you're going to do this when you do the lab that we're going to do after this topic. Okay. So packet filtering technology. So generally, as we've said, packet filtering firewalls determine whether packets can pass based on statically set rules. Statically set rules. So packet filtering technology, let me explain this. So the core technology for packet filtering is access control lists, and packet filtering firewalls determine whether packets can pass based on statically set rules. Based on statically set rules. What that means, for example, here we have two rules. In this rule one, let's interpret rule 1 here. We are saying if a packet has a source address of 1.1.1, which is the address of PC1 here, for example, and the source port is any port number. So when you have a star, we mean any port number. And the destination address is 2.2.2.2, and the destination port is 80. Then permit that packet. So by doing that, what we've done is simply telling this firewall to allow any packet that is coming from that network and is destined to the web server. In the next example here, rule number 2, we are saying if it has 2.2.2 as the source address and the source port is 80 and the destination is 1.1.1 and the port number is any, then we also want to permit. So we are simply allowing the firewall to pass packets from the web server to this particular PC. So this is what we are saying, that these are statically set rules. Statically set rules. Now this per packet inspection. So every packet has to be matched against these rules. So that process is called inspection. So this per packet inspection actually affects the forwarding efficiency of the firewall and can actually make the firewall a bottleneck for packet forwarding on the network. So it also introduces that problem. Okay, so those are simply the paths that we created. So for that reason, they created what we call stateful inspection. So I told you that I was going to tell you about stateful inspection. Now this is the time. Now, let me come back here again. So you see, with per packet inspection, we have to create two rules, for example, for the sending and another one for the receiving. Something like that. I want you to see how stateful inspection does this. Now, with stateful inspection, we only need one rule. We only need one rule. So here, for example, we are saying if a packet is coming from 1.1.1, it's coming from PC1 with any source port number going to the server with a destination port of 80, then permit it. So if the action is permit, a stateful inspection firewall treats all the packets belonging to one connection as a data flow, So how does that happen? Now let's look at step one here. So the PC accesses the web server, so sends a packet to the web server. Now when the firewall receives it, it's going to permit the packet. Other than permitting the packet, it's going to create a session. It's going to create a session. So what a session means, it's simply creating a table saying that anyone that comes in with this address, any other packet that comes in with this address, this port number, and they are going to this guy via this port number. So that is what a session is. We're simply saying that for any other packet that has similar characteristic, of course, that is what we call a data flow, that has similar characteristic, we are simply going to permit them without having to inspect them further. So that is what creating a session is. So what happens is that once that session has been created, the firewall, of course, is going to forward the packet to the internet. Then the web server is going to reply. Now, when the web server replies, when the firewall receives that reply, it's simply going to match the session with this particular information. It's going to match that particular session with this particular information and simply permit the packet. So you see, because we have a session, we are storing a session, we don't have to configure two rules for going to the server and for coming back to the PC, from the server to the PC. So that is what we call stateful inspection, because we use the session mechanism to filter packets. So any question here on stateful inspection? Any question? Okay, so let's move on. So the quintuple information in session entries. So we've just said that the firewall will always create a session. These sessions are going to contain information about the packet. So some of the information that it's going to contain, quintuple means 5. So the protocol type, for example, here it's HTTP, VPN, whatever. The source address, the source port number, the destination port number, and the destination port number. So those 5 are what we are calling the quintuple. So the quintuple information is a session entry that can uniquely determine a connection between communication parties. So on firewall, the time before a session is deleted is called the aging time of the session. So that means that session entries cannot stay forever. They age, they expire. Now, one session indicates a connection between two communication parties. So the collection of multiple sessions is called a session table. So actually, each session is stored on a session table. So that's why they're saying the collection of multiple sessions is called a session table. And the reason as to why sessions age is because of the resources, to minimize resource usage. Because if the session table is too long, again, it's going to increase the time, the lookup time on the table. So that's one, and again, it occupies memory. So that's why we have to delete it after a while. Now let's look at security policies and how they are done. So a security policy controls the firewall to forward and perform content security integrated detection on traffic in security interzones based on certain rules. These rules, the essence is packet filtering. The essence of these rules is packet filtering. So as we said, we are creating different zones so that we can now be able to allow or disallow traffic from one zone to another. So in this particular example, we are disallowing traffic from the untrust zone to the trust zone, while allowing traffic from the trust zone to the untrust zone. So what does that mean? Users of your network here can be able to access the internet, but anyone on the internet cannot be able to access your intranet. This is your intranet. So people from the internet are not supposed to access it. Okay, let's look at the other example here. So we also have the DMZ, where we have servers such as the web server there, .com. So here we are configuring, we are disallowing this particular server from accessing the internet, but we are allowing people from the internet to access the web server. So we can do that by using security policies. So again, please remember the concept of inbound and outbound. So when you're moving from a lower security level to a higher security level, we know trust is 5, trust is 50. So that is configured on the inbound direction. When you're moving the other way around, from higher to lower, that is outbound. Okay. Now, content security integrated detection. Content security integrated detection. When we were looking at the history, of firewalls, we talked of the United Threat Management, UTM, and we said one of the things that it brought was integrated detection. Now, what integrated detection means is that you are not just filtering packets based on where they're coming from and where they are going from, but you are also able to do things like intrusion prevention, check antivirus scanning, URL filtering. So you can also filter based on the URL, the address to where that particular packet is going to, and many other parameters which we are going to look at. Now, in UTM firewalls, this was done for the packet separately, one by one. What that means is that you perform this. So first of all, you have to do detection. So detection is finding out the parameter. For example, the destination address or something. Then you process. That is to check whether it has a deny or permit or something like that. Then after doing that, you now go to the next detection that you want to do, maybe antivirus. Again, you have to detect, then process. Then you move on to the next thing, URL filtering. You detect again, then you process. So that is how UTM firewalls were actually doing. Now, in order to improve the efficiency and the processing speed, this was improved in terms of design in the next generation firewalls. So in the next generation firewalls, we don't do the detections separately because it's going to waste a lot of time. So what we do here is we simply do an integrated detection. So we've specified all the parameters that are needed for each of these detection. So after reading those parameters, we can now go through the list one by one and check, do URL filtering, antivirus procedures, and intrusion prevention processing, among others. So integrated detection performs only once detection and processing on a flow for content security checks, including antivirus and intrusion prevention. So that is on the next generation firewalls. Otherwise, for UTM firewalls, each of the process was doing detection on its own. Now, let's look at some of the parameters that are actually checked by the firewall. So the firewall will analyze traffic and retrieve attributes such as the source address, the destination, a zone actually, source zone. Are you coming from the trust? Are you going to the untrust? So these are zones. Are you coming from DMZ? Are you going to DMZ? Other parameters, IP addresses and the region, destination IP addresses, also the user. So who wants to access what? The service type, the application, is that particular application allowed? The time range, are you allowed to access that particular zone at that particular time? So these conditions can have either a permit or a deny. They'll match either a permit or deny. So for example, after you've been permitted, now they can now profile you. They can now profile you and do other detections such as antivirus, intrusion, URL filtering, file blocking, data filtering, etc., etc. Okay. So how the policy is executed. So the next generation firewall security policy configuration logic. So generally the matching sequence of policies is from the first policy to the last policy. So policy 1, policy 2, up to policy N. Now, the condition can be this. For example, security zone, then you specify the destination zone, source address, you specify the source address, the destination address, the user service, application, time range. These are or, so it can be either. Now, when you match that, you are going to apply a certain action, either permit or deny. Then after you've, for example, been permitted, you can be profiled. We can now check the other things. So if you don't match this policy, it checks the next policy. If you don't match this, it checks the next policy up to the end. If you don't match any policy, the default security policy action is deny. So if you don't match any, then the default is deny. Okay, so we have what we call multi-channel protocols. Multi-channel protocols are protocols that use random ports. Protocols that use random ports. These protocols, they make it complicated to do packet filtering based, for example, on the port number. So pure packet filtering cannot be able to be used to identify the data flow in multi-channel protocols. One of the examples of the multi-channel protocol is TCP. So for example here, FTP. So for example here in FTP, the first part there is what we call the control connection, where they're trying to establish connection. They do the three-way handshake and also do authentication. So during this particular part, when the client wants to connect to the server usually listens on port 21, FTP port 21, but the client will automatically generate a random port number, for example, XXXX, like that. Now, in the next part, this is where now the connection has been established, STP connection, and authentication has been successful. So now they can start sending data. So this is control connection, then this is data connection. So they can now start sending data. Now, before they start sending data, the client has to generate a different port number. For example, YYY. YYY. So you see, it's not using a definite. It's not using a definite port number, and therefore we can't do pure packet filtering based on these port numbers, because we don't know what packet number is going to be. But of course, again, on the data connection, the FTP server has opened TCP port 20 to receive the data. So the problem with multi-channel protocols, I've said, is that it uses random port numbers. Okay. So the solution to that is what we call application specific, not service, specific packet filter, aka ASPF. Application specific packet filter. So how does this work? Let's look at that. So, as we said, we have the control connection there to set up the TCP connection. Then here we have the data connection so that we can be able to exchange data. Now, this guy will generate a random port number. Now, when that happens, at the data connection, when it sends the first packet, the firewall creates what we call a server map. It creates a server map. It creates the server map. So the server map actually saves this particular port number and associates it with this particular IP address. So what happens is that when the firewall receives any FTP packet, it will simply allow it by matching the server map. So check, do I have this destination port number on my server map? So that is what matching is. And therefore, by that, we can be able now to perform what we call So this is what we call application specific packet filtering. So the firewalls detect the application layer data in packets, then automatically obtains information and establishes session entries to ensure normal communication. So this function is called SPF, and the created session entries are called server map entries. Server map entries. So that is how multi-channel protocols are actually handled. So how do we configure a server map entry on a firewall? So we have to specify. The reason as to why it's called, by the way, the reason as to why it's called an application-specific packet filter is because it's most of the time used to detect those application layer protocols that use random ports. So how to configure? We configure it on the firewall. So the command is firewall interzone and trust to DMZ. Then we specify the application layer protocol. So detect FTP. Detect FTP. So that is it. That is how we configure application specific packet filtering. So once you've done that, if, for example, you type display firewall server map, you can see that a certain address, which is the address of this client, has been mapped to a particular port number. So we can be able to trust it. And this was learned as it was coming from the internet. So when this was replying, we actually created that mapping between the destination address and the port number. Now, subsequent packets match the session. So if you do display firewall session table, you can see that the session has actually been created between the IP and the port number for the FTP server, the IP and the random port number for the FTP client. So that is what we call, that is how you configure and verify things to do with application-specific packet filtering. Okay. Any questions so far? We now want to go to netting. Any question? Do you still have the energy to continue? We've done an hour so far. We are only halfway. This is quite a long topic. Okay, so just give me a minute to take a cup of water and then we can proceed. Thank you.
Okay.
Okay, so can we move on?
Yes.
Wonderful. So let's look at NAT. So private network users accessing the internet. So this is something we already know, that within our intranet, we normally use private IP addresses. We normally use private IP addresses, but when we send packets to the internet, they have to be they have to go with a public IP address. Now, most of the time we use what we call source NAT. Source NAT translates only the source address of the packets. So from a private IP address to a public IP address. Now, if multiple users share a few public addresses to access the internet, the source NAT technique can be used. So source NAT is exactly that. So we are not mapping between any other thing, just the source IP address. As the source IP address. Oh, okay. So we have two modes for source NAT. One of them is called NaN, no port address translation, no PAT, and NAPT, NAPT. So with no PAT, only the IP address are translated. With network address, port translation, we translate both the IP address and the port numbers. So these are the two modes for source NAT. So when is this one used? No PAT. When there are not many private users who need to access the internet. So the number of available public addresses is almost the same as the maximum number of concurrent internet access users. So actually, this kind of NATing does not conserve public IP addresses to a great extent, because it just takes, it normally relies on the fact that not all internal users will want to access the internet at the same time. So sometimes you can have maybe a smaller number of public IP addresses than the total number of internal users in your network. But normally it's only for small enterprises, very small enterprises with a few number of internet users. Now, network address port translation used, there are a few public addresses, but many private users who need to access the internet. So when you have such a condition, then we need to use network address port translation. So I'm not going to go through this too much, because these are things we've already done at the associate level. So no PAT is one-to-one network address translation, and no port translation is performed. So just as an example, this host has an address of 192.168.1.2. So NATing is most of the time done by the firewall. So we simply change that to a public IP address, 1.1.1.2. As you can see, the source port numbers actually remain the same. So we don't change the port numbers. So the firewall will have an address pool with a number of public addresses. So for example, here the start address is 1.1.2 up to 1.1.1.10. Normally the ISP will give you a number of continuous public addresses depending on your demand to make configuration and follow-up easy. So here we have, I think, 9 addresses from 2 to 10. Is it 9 or 8? 8, I think. Oh, sorry. So this is how the server map table is going to look like, and this is how the session table is going to look like. So you see, if you're coming from that person going to that person, then we've mapped you, for example, to that. Or this is the destination IP address for the web server and the port. Then this is the network address translation. So this is the private and the port number you've come in with. This is the new public address and port number, source port number that we've given you. Then we have network address port translation. As the name suggests, this is many to one. So we map the private to a public address, and we also change the source port number. So it came in with 1025. We are changing it to 2048 to 2048. So you can look the entry at the session table. You can actually see the source IP and the source port number, and you can see the new source IP and a new port number 2048. So if they are going to this person, so if we've allowed that on the firewall, then the firewall will also allow, when we get a reply from the server, the firewall is going to match it from this session table and still allow. So that is what we call stateful packet inspection, because we are saving in session tables. Okay, so an example: configuration, NAPT, network address port translation. So a next generation firewall serves as a security gateway at the border of an enterprise network. So a source NAT policy must be configured on the next generation firewall to allow users in network segment 10.1.1.0/24 to access the internet. So in addition to public IP addresses of interfaces on the egress gateway, the enterprise applies for 2 IP addresses. So the enterprise has 2 public addresses, 1.1.1.10 and 1.1.1.11 for NATs. So the network environment is shown in the figure. So the router is an access gateway provided by the ISP. So how do we do that? So this table is simply showing the data planning, simply how to configure each of the interfaces. So this interface 01 is supposed to be configured with that IP address and be configured as the trust zone, because it's the one that is connecting to our intranet. This one configured with that IP address, public IP address, and configured as an untrust zone. Then we are supposed to allow private network allowed to access the internet. So we should allow this. We create a policy for that. We are also supposed to create a NATing rule that can map from this range Then also we are supposed to create routing. For example, we are supposed to create in the next generation firewall a static route to the internet, to the ISP router. And we're also supposed to create a null pointer to the ISP router again to avoid black hole and loops. We're also supposed to create a static route between that. So let's do that. So in step number 1 here, we are simply configuring. In the first part, we are configuring the IP address for the interface. In the second part, we are creating the security zones and adding the respective interfaces. So as an example, you can see we are creating zone trust. We are setting the security level to 85 and adding interface 0/0/1, this one here. So this is the trust zone. After that, we need to configure the policy to allow computers in our network to access the internet. So we are giving it the name policy sec1. A source is from trust to untrust zone. If it's coming with a source address from that network, and the action is permit. So after doing that, step number 3, we can create a NAT address pool. So the command to do that is NAT address group, then you give it a name like address group 1, then you specify the range. And then after that, we configure the source NAT policy. So NAT policy, then rule name policy NAT1. So from trust to untrust. If it has a source address from this network. Action, we want to implement NATing using address group. So action NAT address group. The address group we just created in step 3, address group 1 there. Then number 5, we are simply creating a default route. To the ISP router, so that if we receive any packet, if the firewall receives any packets, it will simply send it to that next hop. Okay, so that is it. So you're going to do that in the lab. So we've seen how private network users can access the internet. Now we want to see the other direction. How can the internet users access our intranet servers? We say our intranet servers that are supposed to be accessed from the internet are put in the DMZ. So we want to see how that can be achieved. So internet users accessing intranet servers. So using the NAT function, internet users can use public addresses to access intranet servers. So this function maps one public address to the private address of an intranet server. So again here, as we said, the server has to be placed on the DMZ. In your intranet, your server will have a private address. But now, for people to be able to access it from the internet, it must be associated with a public address. So that particular mapping will be configured on the firewall. And that particular mapping can be a static NAT. So let's see. so that it's permanent. The same public address will always be translated to the same private address and vice versa. So this particular type of NAT is called actually NAT server. The official name is NAT server. NAT server. Now, with NAT server, the same, so you see here, at the destination, this host will enter a public IP address 1.1.1.10. Now, when that comes in the firewall will translate that to the private address of the server, like that. So with NAT server, it provides static mappings between the public and the private address. You can still use port translation, but it's optional. So if we look at the session table, you can see the source. So the source is this guy, and the port number, random port number 3535. Destination is a public IP address of our server and port 80 because they're accessing our web server. But in the session table, we know that when this comes in, we are supposed to translate it to 192.168.1.2 on port 80. So that is how that is achieved. So again, how can we configure this? So our next generation firewall serves as a security gateway at the border of an enterprise network. So to allow intranet web servers to provide services for internet users, we need to configure NAT server on the next generation firewall. In addition to public IP address of the interface on the egress gateway, the enterprise applies for an IP address 1.1.1.10 for NAT. So this is a public IP address. So the network environment is shown in the figure. The router is an access gateway provided by the ISP. So the data planning, so this interface connects to the router that has been provided by the ISP. So it connects us to the internet. So we are going to configure it as Untrust zone. This one is connecting to our DMZ. So we configure it as a DMZ. And then we need to do server mapping. So we create a static NAT. Then we are supposed to also configure routing. So a default route to go to the router that has been provided by the ISP, and a route to prevent loops between the next generation firewall and the router. So it points to null 0 as the next hop. So first thing we're doing is configuring the IP address for the interfaces. Then the next thing we're doing is creating the two trust zone. So Untrust and DMZ. Untrust, we set a priority of 5 and add interface 1 there. DMZ, we set a priority of 50 and we add interface 2 to the DMZ. Then we configure the policy to match these particular zones that we have created. So the policy goes security-policy, rule name, policy sec1. Then we are allowing a source zone of Untrust, destination zone of DMZ. So we are allowing coming in from Untrust to DMZ. If the destination address, so this time we are using the destination address, is 10.2.0.0/24 there, the mask, you can see it, the action is permit. So after we've done that, we can now configure static NAT on step number 3 here. So we create it like this. This is how we create static NAT. So NAT server NAT server, and then you give it a name, policy NAT web, protocol TCP, when you're going outside. So that is global 1.1.1.10, port 8080. Inside, you're going to translate that to the IP address of our web server, 10.2.0.7. www will still give the port 8080. Then we are using the command there, no reverse. So we cannot do the opposite. We cannot do the opposite. We cannot move from here. It cannot be translated. This nothing cannot be translated the other way around. Okay, so that is it about nothing. We're almost done. You can take a minute and have a stretch before we look at attack defense.
Okay.
Okay, so let's move on. So the attack defense application scenario. So generally, you'll deploy your firewall just before the router that is connecting you to the internet, so that if an attacker wants to attack your intranet, then the firewall is going to detect that attack and actually stop it. Now, the firewall can actually be able to prevent various types of attacks, such as the common denial of service attacks, and also what we call single packet attacks. So we are going to look at some of the DDoS attacks and also single packet attacks. So with the distributed denial of service attack, what the attacker does, so this is the attacker. So the attacker hacks a computer in your network, then floods, uses attacks other computers. They attack other computers. These computers are known as zombie hosts because they are not even aware that they are under attack and they are being used for an attack. Now, actually, they are being used so that all of them can send packets to a particular attack target. So you're here. Now, the main problem with this kind of attack is that you are hiding you're hiding behind a system that you've already captured. So getting you becomes very difficult. So once you've captured this one, you now tell this one to instruct all the other machines to send massive amounts of packets to a particular target. So when this happens, again, network services might deteriorate or become unavailable completely because of massive congestion in your network. So DDoS attackers control zombie hosts to send large number of attack packets to targets. So according to the attack mode, these DDoS attacks can be classified into either traffic attacks. Now, traffic attacks, we can either have SYN or UDP flood. So other than traffic attacks, we can also have what we call application layer attacks, where they are using an application like the browser to send HTTP floods, HTTPS floods, or even DNS floods. So the good thing is that next generation firewalls can defend against common DDoS attacks, such as SYN flood, UDP flood, etc., etc. So here, they're just showing how to configure configuration commands for SYN flood and UDP flood attack defense. So they're just trying to show how to, for example, set DDoS attack defense parameters. So they tell you, for example, you need to enable traffic statistics first, and the command to do that is that anti-DDoS flow-statistic space enable. For SYN flood attack defense, you need to first configure global SYN flood attack defense by using that command and the rest. For configuring UDP attack defense, for example, you first of all need to configure global UDP flood attack defense. So you begin by configuring the global UDP flood attack defense by using this particular command. So when you get time, you can go deeper into them and understand them better. I'm sure you're going to do some of these things in the lab that you're just about to do. So other than denial, distributed denial of service attacks, we also have single packet attacks. Now, single packet attacks are the most common distributed denial of service attacks, and most are initiated by individuals. So some of them, single packet attacks, include like the malformed packets. You remember that, like the IP smurf attack that we just looked at in the previous topic. So it's one of the single packet attack. Scanning attack, like port scanning, IP sweep. We also have special control packet attacks, like large ICMP packets attacks, ICMP redirect packet attack, etc, etc. So again, when you get some time, make sure that you read about some of these attacks. Now, configuration suggestion for single packet attack defense. So they suggest that we enable the following features to prevent single packet attack, and we disable the following. The reason is enabling attack defense functions that greatly consume firewall performance is not recommended. So that's why they're suggesting that we don't necessarily need to enable these ones. If we enable all of them, our firewall is going to be overwhelmed, and it's going to create a bottleneck in our network. but at basic, we can always configure SMART attack defense, land attack defense, etc., in order to prevent single packet attacks. So the configuration commands, for example, for the SMART attack defense, how to enable it, the command is firewall defend SMART enable. For enabling land attack defense, the command is firewall defend land enable, etc. So you're going to meet some of those again in the lab. Thank you very much, ladies and gentlemen, for your patience. That is the end of this chapter. Any question? So how do we determine the trust degree of a security zone on a firewall? Any volunteer? How do we determine the trust degree of a security zone on a firewall? Okay, so we do so by using the security levels. Remember, each zone has a certain, is associated with a certain security level or trust degree. Like trust is 85, local zone is 100, DMZ is 50, and trust is 5. So we use actually the security level to achieve that. Asanteni sana.